Hello guys, welcome back to another exciting video. In this video, we're going to continue with our series on working with agentic AI systems. So in the last video, we have looked at memory part 1. So this is going to be memory part 2. So in this case, we're going to take everything that we learned from the last video, which was more of a theoretical thing, and we're going to put it into a practical use. So we're going to go ahead and build a simple, very simple customer support agent that can use the long-term memory to store user information like contact details, what are their preferences and products that they're interested in. Basically a chatbot for maybe like an e-commerce or an online store, right? And then you're going to use the short-term memory to keep track of the whole conversation so that you can ask the bot any question about the current session of conversation you're having. But it also have the long-term memory to understand what your contact, what your preferences and stuff like that. And based on that, it can give you product recommendations and stuff like that, right? So let's jump into it, okay? So this is just a course overview. This is what everything that we'll be covering in this series. Again, I might divert to other areas because as like things is always changing, right? Technology is always changing. There are always new things coming into the field, and I want to be able to provide you guys the best of the best, right? So I might change a bit of and turn left or right, and then do some tweaks different from this outline right here. But I will let you know whenever I do that, right? Yo. Okay, so let's jump into. So in this video, we're going to look at three main things, right? The recap from understanding, basically a recap of the last video about memory. So that for those of you who haven't watched the last video, I would encourage you to go ahead and really watch the video. And yeah, even if you don't want to watch, I'll just give you a very brief, super brief, so it won't be that helpful unless you have watched the last video. But again, if you want to just skip the last video, it's still fine. But I highly recommend you go back and watch that video. So do a recap of that video, which is a previous video. We'll do have a playground, understand how long-term memory works, and then finally we'll go ahead and create our customer support agent with both long-term memory and short-term memory. Okay, so in the last video, we talked about memory, right? So the chatbot being able to understand and recall information, previous information, right, through the conversation or through multiple conversations. So we talked about a short term memory, also called the thread scope memory, right, whereby the chatbot only remembers conversations within a given thread of conversations. So, for example, if you go on ChatGPT and you click on new chat, the chatbot only remembers conversation within that specific chat, right? If you create a new chat, it doesn't remember anything from the previous chat. Can be an example of thread scope memory. And we also talk about long-term memory or cross-section or cross-thread memory. Basically, the chatbot remembers information from multiple chat sessions. So if you go on ChatGPT, you create a new chat session and you have a conversation with the chatbot, and maybe the chatbot picks some information from there and store it in its long-term memory. Then even if you go to another chat or 10 different chats, it will still remember that information that it picked from the first chat session, right? That's its long-term memory. This is just a recap of the last video, okay? So one thing we need to add on to the last videos is short-term memories are implemented using something we call checkpointers in LangGraph, and their long-term memories are also implemented using something we call memory stores or a store. And we'll look at all this just in a second. Okay, so now let's go ahead and create a simple playground so we can experiment with long-term memory and then get our hands dirty. Okay, let's jump into it right here. So I have my code open up right here. So I'm going to go, I simply add another folder. I'm going to call this one projects. Right, this is our first project, and we're going to call it create a first. We're going to call it customer support agent. So customer underscore support agent long and short term memory. Okay, that's a bit of a long name, so but it's good to be descriptive. IPYNB. It's good to be descriptive and be confused later on in the future. So I'm just gonna keep it very descriptive. So make sure that you load in your virtual environment. Okay, so I've loaded my virtual environment and we can get started. So I'm gonna create something. I say customer support agent with long and short term memory. Okay, memory. If I can get the spelling right. Good. So once we have that done, the first thing we're going to go ahead and do is bring in the basic imports to load in our environment variables. So to do that, I'm going to go ahead and say import and make sure this is a Python cell. So select Python right here. So I'm going to say import OS, the OS module from Python. I'm going to say from dot env, I'm going to go ahead and import load env. I'm also going to go ahead and import, yeah, I think those are things I need for now to load in my environment variables. So to load in environment variables, I'm going to go ahead and use this right here. So I'm going to go ahead and simply say the following, and I'm going to go ahead and say os.environment environment, and I'm going to go ahead and simply say lang chain underscore project, and give this a project name. It's going to be equals to LangGraph store LangGraph customer support agent tutorial. Okay, and I'm also going to go ahead and simply say os.environment. I'm going to go ahead and create another environment variable right here. We're going to call this one lang chain underscore training tracing underscore version 2. And I'm going to explain to you what all this is, so just bear with me. So I'm going to say true, say this to be true. So this is going to be LangChain, like LangChain project, and the name of the project. You also have another one. Let me just close the side panel so that you guys can see this full. You also have another one called LangChain tracing version 2, and you're going to use this to trace our project. And this we're using something called Langsmith. Okay, so we'll look at all this in a second. For now, just keep this code. If you haven't really understood it, if it's fine, just keep this code in case you're getting any errors. You can just keep this code, right? But we'll look at Langsmith later on in other videos. So it's just a tool to developed by LangChain to help you track the performance of these AI models and the things that they're doing in a more visual way. Okay, so once we have done that, let's go ahead and import some stuff. Okay, so let's add in a comment here. So this is going to be basic imports. So for basic imports, what we're going to go ahead and do, we're going to bring in a couple of libraries right here. I'm going to go ahead and import UUID. We're going to use this for identify different memories. Also going to say from langgraph.store, I'm going to go store.memory. I'm going to go ahead and import in memory store. So I'm going to use this for storing the long-term memory. Okay. So this I mentioned that long-term memory is stored using stores, right? Is handled using a class that is called stores in LangChain. So we're going to use an in-memory store. You can use different stores like Postgres, MySQL, SQLite. You can use all that to store memory. But for now, I'm going to use an in-memory store. Just something very simple. Okay. In the other videos, we'll go ahead and do much more advanced stuff. So I'm going to say in memory underscore store is going to be equals to an instance of this in-memory store that we imported. Run that. So this is going to create for us our long-term memory object. So once we have this memory object created, now let's go ahead and store some information within our long-term memory. So store information in long-term memory. Okay, good. So we have created a long-term memory object, which is this right here. I'm going to copy it, move it right here, and you're going to go ahead and add something to it. So to add basically memory to our long-term memory, we'll need a couple of things. So we need a namespace for our memory to save our memory. So I'm going to go ahead and say it's going to be our namespace for the memory. Okay, memory to save. And I'm going to go ahead and say me doing customer underscore ID. So each customer is going to have a unique ID that you're going to use to track this customer. And this will be typically coming from your backend applications if you're building a real world application. But for now, we're just going to be using some dummy data. So I'm going to say namespace underscore for underscore memory. Namespace for the memory that you're going to handle is going to be equals to a tuple or a tuple. You're going to have a customer ID, and you're going to have called this namespace customer underscore interactions. That's it. So once we have this right there, we can go ahead and save the memory. So to save the memory, we need what we call keys. So it uses kind of like key value pair ways to save information within a given namespace. So we have a namespace. Within that namespace, we have key value pairs that we use to store the different information. So each, that's like a Python dictionary, each key needs to be unique. So we're going to be using our UUID for that. So let's say save memory, save a memory. Okay, let me get that spelling right. Okay, save memory and to namespace. I just have my mic in front of me. Sometimes it's difficult to type as key value pairs. Okay, that's it. You're also going to go and create a key, and key is going to be equal to a string of UUID where we import the UUID. So UUID.UUID4. Okay, and just create a simple UUID. So once you have the simple UUID created, we're going to case value is going to be equals to a Python dictionary. You're going to have name, and the name is going to be in this case you're trying to store some information within this memory, right? So I'm just going to have a dictionary. I'm going to go ahead and simply say name, and the name is going to be, let's say, John Doe. And I can go ahead and also store, let's say, John Doe's email in the long-term memory, because uh, John Doe, John Doe at example.com, just like that. That's a simple email, right? So once we have that there, we can go ahead and simply store this in memory. So I'm going to say this is going to be now save the memory to disk, right? So in this case, we're using memory, in memory, kind of like, I hope you get the point. It is a memory that exists within our disk or memory, something of that sort. So in memory, sorry, this is in memory store dot, you're going to say put. That's where you add message to memory. You're going to save, start with a namespace, and you're going to say our namespace is going to be namespace for memory, and you're going to pass in the key. The key is going to be the key that we created above, the UID string. You're going to say the value, and the value is going to be the values that we have right there. Okay, awesome. So once we run this, it's going to go ahead and store the memory inside of our disk. Okay, so once we have the memory stored within disk, we can go ahead and search this memory, search the memory space, and retrieve the memory that we need. So let's go ahead and simply search memory. So I'm going to create a simple just markdown. I'm going to simply say search memory, just like this, and then press enter. So to search the memory, what you're going to go ahead and do is simply you're going to do the following. So I'm going to say memories. Let's create a variable to store all the memories that we're going to retrieve. I'm going to say install memory dot search. So to search, you're going to use the namespace to search that memory. So I'm going to say namespace and then pass in that namespace right there. Awesome. So now we can actually go ahead and simply check the type of this memory. What object type are we getting back? So memories, just like that. Let's land this. It's a list type. Okay. So let's try to print this and see what we get back. So copy this, paste over here, and then let's print it. So this is what we get back basically, right? So now that doesn't make any sense to us. So let's try to make sense of this by converting this into, you're going to go ahead and get the first element of this list, because it's a list which has this lang store objects. So we're going to get the first object dot and say dict, and then this will convert it to a Python dictionary that you can see. So good. So this is how the memory looks like. It has a value, which is exactly what we stored within that memory. It has a key, which is a UID you created. So if I go ahead and make a call right and say print key, and if I run that, you can see this is the key that we created, and this is right here, right? So let me delete that. You also have the namespace, right? The customer's ID, and we call it customer interaction. So this ID will be different from different customers. So each customer can have their own long-term memory stored about them, like what they like, what are their preferences, what are their email contacts, and what kind of products to recommend to them based on that kind of thing. The memory, right? So we also have created at when it was created. We have the updated at when it was last updated. Okay, this case is timestamps are more or less the same. Awesome. So once we have this done, we can actually go ahead and do more. We can actually just print things out in more depth and see what we can get. So you can get the value. Just like you have a Python dictionary, you can actually interact with this more or less the same. Okay. So you can actually do this. Let me just copy this right here and just put it right here. So we're going to go ahead and simply do this and just say dot key. And yeah, let's try to run this. This is the key that we have. You can also go ahead and print the dot value and just run that, and you can see this is the memory's value, right? Namespace name is John Doe, email is this one, right? So that's what we're storing about the user in our long-term memory. So now let's getting memory keys and values. So you can also get the memory from the keys and the value using the keys and the value. So to do that, let me just show you how we do that. So this is basically getting memory using key and values, key and value. Okay, so let me just go ahead and show you how to do that. Basically, key and not value. This is actually namespace. Namespace. All right, you talk about the namespace already. So I'm going to go ahead and simply say memory is going to be equals to in memory store dot. You're going to say get. Let's say use the get method. You pass in the namespace. It's going to be our namespace right here. We also pass in the key, and you pass in the key that we have. So if I run this, we can, let me just copy this, paste it right here. You're going to convert this to a Python dictionary straight. So dict, and then, sorry, my bad. Okay, let me get that right. So run this. Yeah, so you can see how you can also get the memory from using the namespace and the key. Okay, so you get back the same response. So the namespace, this one, and the key, right? Awesome. Good. So once we have that right there, we can go ahead and yeah, that's basically what I wanted us to cover in the playground, really. So basically creating memory, storing information within that memory. We can also delete the information if you want to. Let me show you how to delete that. So to delete memory, to delete something from the memory, just say, let me just add in comment right here. So when you guys check out this repository later, you can actually see what you're doing. So delete, delete memory. Okay. So to delete memory is actually very, very simple. So okay, delete has an E right here. So my bad. So delete memory, and it's very, very simple to delete memory. So what all you have to do is call the memory object in memory store object. So in memory store dot delete, and you pass in the namespace. It's gonna be our namespace, and you pass in the key, which is going to be our key. That's it. And if you run this, it's gonna delete the memory out of it. So if I go back in here and try to get it, we shouldn't get anything back. So go in here and then run this. Okay, you can see attribute has not, because it's a none type, this memory type doesn't exist. So you have to keep in a check. So you can say if memory and then run this. Good, right? So there's no memory because it's none. That's how you can get the dict object, right? So keeping that check there just to make sure that in case the memory doesn't exist, like in our case we deleted it, then your code doesn't have issues. Awesome. So once we're done with this, yeah, that's all I wanted us to cover in the playground implementation. Just getting to create a simple long-term memory. In this case, you're using a disk on disk memory. You can use something like Postgres or more permanent storage, SQLite or something like of that sort. Okay, but in this case, you're just trying to keep it simple. Just give you an overview of long-term memory, right? So once we have this whole idea of the long-term memory, now we can go ahead and create our agent. Awesome. So to create our agent, a couple of things we're going to go ahead and do. So we're going to go ahead and first create a model, right? Our language model or our chat model. And you're going to use this model. So let's go ahead and start doing that right here. So I'm going to go in here, and this is going to be creating customer support agent with long and short term memory, just like that. So once we have this, the first thing we're going to go ahead and do is the following. So we're going to go ahead and create a creating model, just like this. And to create the model, what you see me going to go ahead and do is the following. So we're going to say from lang chain Anthropic, I'm going to go ahead and import chat. Let me see chat. Yeah, chat Anthropic right here. And once we have that, I'm going to go ahead and simply say model, or chat model is going to be equals to the chat model, and you're going to give it a temperature, and you're going to say 0, 0.0 or 0, 0.1. Okay, just to give us a bit of randomness. And I'm going to say model. A model that you're going to be using is going to be the following. So I'm going to use Claude, the Claude model. So Claude hyphen 3 Opus hyphen 2024 and then 229. That's the model name. Okay, so Claude 3 Opus 2024 229 2024 0229. Okay, that's a bit of a complicated model name. Anyway, yeah, so once you have that, you're going to say API key, and you're going to say os.environment.get, and I called it Anthropic underscore API underscore key, just like that. And let me run that right there. Good. So once we have that done, I need to go ahead and create the agent prompts. So we're going to have the agent prompt, and this prompt is going to be too long, so just not to waste your time and you guys having to watch me type all this. I'm just going to copy this and paste it, and I'll be back recording, right? Yeah, so I've copy pasted the information right here. So you can see I have the company name, which is just like this fictional company, right? Prince, COVID Prince PLC. Yeah, maybe in the future this could actually be a real company. Anyway, yeah, so it says a model system message. You're a helpful customer support assistant for this company, called Prince PLC, using the customer's history to provide relevant and personalized support, right? So we're telling it to use the customer's information which you're storing in the long-term memory to do that. So, and also we are providing in the chat history of that specific bot, right? That specific conversation. This is basically going to be the short-term memory. So update the customer profile with new support interaction details. So We are telling the bot that it should capture information like the contact, the products that they purchased, their previous issues or resolutions, their preferences, their special circumstances. Focus on verified support interactions only. Summarize key details clearly. Update profile based on this conversation. So we're just telling the bot to pick up this kind of information from the conversation. So anytime there's any preference information such as products, communication, way, special circumstances, it picks that and updates the long-term memory. So I just telling the bot, listen for this kind of information, and once this kind of information is present, kindly go ahead and update the long-term memory. Okay, that's it. Okay, now let's now that you have done that, now let's go ahead and create some nodes that our agent is going to be using, right? Okay, so let's go ahead and create the nodes right here. So it's going to be called nodes, just like that. So to create the nodes, what you're going to go ahead and do, you're going to go ahead and do the following. You're going to say from ipy python dot display. I'm going to go ahead and display. Okay, import image. Also going to go ahead and import display right here. Okay, so I'm going to say from LangGraph dot check pointer. Remember we talked about check pointers used for short-term memory. Yeah. So dot check pointer. I'm going to memory. I'm going to go ahead and import memory saver. Okay, that's for short-term memory. We're going to say from LangGraph. Again, the other videos I'll make a video going in depth about short-term memory. In this case, we looked at only long-term memory. So I'll make a video. There is a lot of things that we can talk about in terms of short-term memory, because you have to talk about summarization, filtration, and all those other different techniques to maintain short-term memory. We don't want to keep all the conversation within a given session into it to make a request to the large language model each time. That would be really expensive, and you might overflow context window. So we'll look at short-term memory in depth later on in other videos, right? Okay, so once I look at that, you're going to say graph. The graph, you're going to go ahead and import the state graph. State graph, you're going to go ahead and import message, message state. You're also going to go ahead and import start. You're also going to go ahead and import end. Okay, so let's say from LangGraph dot store dot base. I'm going to go ahead and import the base store right there. So let me just move this up so you guys can see this clearly. I'm also going to say from langchain dot store langchain underscore core dot messages. I'm going to go ahead and import the human message. So that's the boring part of it. Just bear with me. I know it's really boring to doing all these imports. So I'm going to say from langchain.core.runnable.config, I'm going to go ahead and import runnable config. Okay, enough of the boring imports. Now let's get doing something interesting. So we're going to go and create a simple node, and this node is going to handle updating the memory and stuff like that, right? Getting memory. This is going to be calling our node, basically our LLM, right? Call the model. So I'm going to go ahead and simply get the code. I have all this code on GitHub already. I'm going to share the link with you guys. So just to save on time, in fact, I should have copied all the imports as well. But anyway, yeah, that's the mistakes already done. So let's move ahead. So this is just going to be generate AI responses using the customer context and memory. So it's going to be using the short-term memory and the long-term memory to call the AI agent and then get information that way, right? So we have memory right here, and this is basically a store, a LangChain store that get. Remember how to get long-term memory. You can use a namespace and key. So you're getting the memory, and then finally you're getting the values, and then finally going to go ahead and update the information. So instead of the message, you're getting the customer data field, and you're going to go ahead and update it. If it doesn't exist, you're going to say no existing memory found, basically. So we're using only the long-term memory to update this information, right? Awesome. So once we have this right there, we can go ahead and simply run this code. So we're going to go ahead and generate a response using this. So we're going to get system message.format. We're going to pass in history as a customer as a long-term memory. In this case, you can also use a short-term memory to pass information. That's actually something you should do, because right now you're only using the long-term memory to update this information, because I really want us to focus on long-term memory in this video, right? So in the next video, we'll look at short-term memory in depth. Okay, so for now, we're only going to be using long-term memory for the agent to update the long-term memory and stuff like that, right? Okay, so once we have that, now we're also going to go ahead and have another node, and this node is going to be update the customer interactions in previous in a persistent storage. So again, this way we're going to going ahead and updating the memory. So this is going to be retrieving the information from the long-term memory and then using it to call the LLM. And we're also going to have another node that's going to be dedicated to just updating the memory, which is in this case our short long-term memory. So I'm going to go ahead and simply copy this and then move it in here. So make sure I have this, I run this, and I'm going to paste this right here and I run this as well. So this is what it simply does. So basically it picks a long-term memory using the key, the namespace and the key, and then basically gets the value, right? And then after that, we're going to go ahead and update our prompt using the history. And then finally, we're going to go ahead and generate, ask the model to update the memory. So this is basically creating history. So it's going to use this prompt right here, which we have right here, to pick things like the customer's history, their product usage, their previous purchase. So that's basically what you're trying to do in this case right here, to write memory. Basically asking it to analyze the conversation and pick up the information that we want, and then update our memory store. That's basically, remember we have used the put method, namespace key, and then this, right? Awesome. So once we have this right here, run this. And we've already seen all this about running, calling chat models and all this. So I'm not going to go ahead about it. You can check the first videos or the beginning videos in this series. So now that we have that, now let's go ahead and build our actual agent. So to build the actual agent, I'm just going to go ahead and copy the code here. All the code is on GitHub, the link in the description of the video. Just to save on time, you don't have to watch me type all this. You can always read the comments and stuff like that in case you are lost anywhere. So basically, we are creating the short-term memory. We're also creating the long-term memory. And you're passing in the short-term memory and the long-term memory to our graph, right? So once we have this, we run this right here. Again, this session, we're going to focus mainly on long-term memory, just to save effects. In the next upcoming videos, we'll focus more on short-term memory. So don't worry about the long-term memory for now. So we're going to say within underscore thread memory is going to be equals to memory. Let me see right here. So it's going to be equal to memory save. I already have that already defined. So what this simply does is this is basically how we are creating the short-term memory. So this is a long-term memory. I've already looked at this already. Now we're working with the short-term memory as well, which we'll look at in the next video. So don't worry about it. This is basically what we are creating in within thread memory, which is short-term memory. So don't worry about that. We'll cover that later on in other videos. In this case, I just want to focus on the long-term, the cross thread memory. Okay, so once we have that, now let's try to display the graph. So we're going to say display, and I'm going to pass in image object. I'm just going to take in our graph.get underscore graph, which is this right here, and we're going to go ahead and simply say x-ray. I'm going to say equals to 1, and you're going to go ahead and say dot draw. This is draw mermaid png. Call this. That's all we need to do. So run this, and you're going to go ahead and see that graph right here, right? So we have our start, and then we call our model, which answers the question, pulling information from the memory. Also, we can also update this. So you can also update this and pull information not only from the memory, you can also pull information from the long-term memory as well, right? Yeah, you can also pull information from the long-term memory as well. So we can have a short-term memory and you can have long-term memory. In this case, you're only focusing on the short-term, the long-term memory. You can also pull information from the long-term memory and you generate a summary or something like that and pass it into this system prompt. And we'll look at that later on. I just want to focus on the long-term memory for now. I think, I know you might be thinking we went upside down. We should have started with short-term memory and long-term memory, but I just feel like let's start with long-term memory and then short-term memory. Anyway, all the roads lead to the same destination, right? So now that we have this, we can go ahead and actually stream the content back. So to stream content in LangGraph, there are two main methods. There's a stream method, which streams content as asynchronously. Also, we have a stream method, which is streams content asynchronously, right? And also have the values and updates. So when it comes to graph state streaming, LangGraph supports a few methods. There's the values. This is used to stream the full state of the graph after each node is called. That's what it does. So it streams the full state of the graph after each individual node is called. We also have updates. This is which is another way of streaming. This is used to stream updates made to the state of the graph, like the graph state itself. So we can set the above using the stream method, stream modes, my bad. So let's go ahead and do that right here. So just to save on time, I'm going to go ahead and copy this over as well. And I'm just going to go ahead and copy this and bring it right here. Okay, so we are saying our customer, our current trade is 1, our customer ID is 1. You're going to go ahead and add in a message. Hey, my name is John. I would love to know more about your PCs. So we're going to pretend that this is actually selling PCs, right? So we go in here and then pass in the message, which is basically our user input. We pass in config and we pass in the stream mode, which is streaming values. And it's going to, what streaming values does, this option is used to stream the full state of the graph after each node is called. Okay, so that's what we're going to be using. So the stream format, and you're passing the config and the message right here, and you're calling the stream graph.stream. So this is going to stream it synchronously. We also have a stream which can stream asynchronously, right? So yeah, so once I run that, you can see we get back the responses. So I say my name is John Doe, and I would like to know more about your graph. So okay, so I get authentication field right here. This is because of my API key. So let me just go ahead and change. I got the email yesterday saying I ran out of tokens. So let me just go ahead and update my API key, and I'll be back recording. So make sure that you have this stopped. So basically you can see this information right here goes, hi John, it's great to hear from you. I would be happy to provide more information about our PCs, and goes ahead and some key features for our PCs include, and then provides a bunch of information right here. In this case, you can connect this to your actual database, which can pull information from your database. So yeah, so basically it's just a conversation. So I need to go ahead and fix, add in my correct API key and make more payments so that I can continue recording. So let me just do that and I'll be back recording. Okay guys, so I'm just back recording. I've updated my I have my env credits sorted. So you have to run ahead and run this again, and also make sure that you run this method. I forgot to run this. So this loads the environment variables into memory. So since I have changed my environment variable, my API key, basically I have to rerun this to reload it into memory. Okay, once you have that, let's go ahead and simply test this out one more time. Hopefully it picks it up. We'll run this and let's see if this goes through. So hello, my name is John. This is a message from the user. So in the long-term memory, we expect it to pick information like the username and what their preferences are, right? In this case, just a username, because that's what one of the things is set contact. So it says, hello, John. I apologize for having an issue with your customer profile on file. As a new customer. I will be more general overview of your PC offering that we call PLC, and then blah 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 blah, and then that's all, right? Awesome. So we can prompt this model to write kind of like an email format, right? So again, yeah, it's just prompting issue. So once we have that done, we can go ahead and let's try to simulate a real conversation. So this is the first round, the user's input, and then the AI response. Now let's go ahead and do another second round, and let's see what the agent stores this time around. So we're just simulating a conversation basically with code, and paste this right here, run this. So we can say, hey, my last purchase, the latest generation Intel processor based on PCs, and it worked really well. What are your prices on these models? So I just said, hey, I like PCs with Intel processors. Okay, so the user is simply saying, I like Intel processor. So I think you should pick that as a preference, that this user actually likes Intel processors or Intel based kind of PCs. Okay, we get an error right here. It says name error, overload error, message overloaded. Okay, let's try this one more time and let's see. So yeah, message, you pass in a message, gonna be the user's messages right here, and then config, and then the stream mode. Okay, so that should run fine. Let's see where the error is here. Yeah, so it looks like you're getting this error right here. So sometimes you get this error, and this is from Anthropic's API. So sometimes maybe their servers are overloaded or something like that. So you get this kind of error message. But you just keep trying. Sometimes it goes through, sometimes really just has an issue and then doesn't go through. But in this case, let's just hope the APIs are not overloaded, and we can handle this request and answer this question. Okay, so that for now, that's the current state of the model providers. It's just a lot of demand on their services. Okay, so while this done, even if it doesn't go through, you can proceed ahead, and okay, now it went through and it goes ahead and answer. So sometimes you might get this. So in this case, you're like you're not in a real production environment. If you're in a real production environment, then you have to find a way to handle this kind of error when dealing with customers. So Okay, but anyway, let's put that aside, and you can see it provides us information on the Intel PCs. You can see, right? Provides us information on Intel PCs because we say we love Intel. So in my customer long-term memory, I need to see two things I expect. In the first round of conversation, I expect it to pick up my name. I expect it to pick John Doe as a name. In the second round, I expect it to pick the Intel processors as a preference. And the last purchase as also Intel PCs. So let's see if that's the case. So we can do that right here by checking the memory. We can go ahead and simply say for key. Okay, let me get that right. So for key comma value in existing, let's say, let me just say existing. Let me just see if I can get this memory right here. So I'm going to go ahead and actually load in the existing memory. So to do that, you're going to go ahead and do the following right here. So we need to actually load that in. So we're going to say customer ID is one, right? We say this one. And then you're going to say my namespace is going to be namespace, space is going to be equals to the following tuple of customer underscore interactions. And then you're going to say customer ID. So previously we said customer ID and then customer interaction. In this case, we interchanged it. Doesn't really matter. So we're going to say existing underscore memory is going to be equals to the following. We're going to say across threaded memory dot get namespace. Gonna be the namespace that we have. We're also going to pass in the key as the customer data. The customer, yeah, we call it customer data memory, and this can be found here in here. So if you go up here in here, we add it in here. Customer interactions. No, customer data. That's the key that we used. So copy that, and then we can go down here and place it in here. Paste it in here, and then we can go ahead and simply convert this to a Python dictionary, and we can see that. So close the side panel. So this is bigger. So we're going to say existing memory dot dict, and then let's run that. So you can see the memory right here. So you can see the customer interactions is picking all this in. The name is John Doe. The contact history initially purchased PC offering and requested for more information. Okay, it collected some permanent information about this user. We can print this out in a more detailed way, so we can just do the form. So we say for key comma value in existing memory dot get dot dict dictionary. Okay, and then get, you're going to get value and then dot items. So this is it. You're getting the values. This is another dictionary. You're getting the item, which is a key value pair, and that's what you're going to be printing out. Okay, so converting this into a Python dictionary, the dictionary looks like this. You're getting the value field, which is this, and you're getting the items of it, which is also a key value pair, which is we're storing K for the key and V for the value. So I'm going to say print K and V. So let's run this and let's see what we get. So the customer interaction, the customer profile, name is John Doe, contact history initially required about PCs, following up expressing in Intel process-based models. So you can see it picked up all that information. Product usage. So previously the customer purchased Intel. Perfect. So you can see it's picking up the preferences of this customer. Preferences, prefers, and has had good experience with Intel processors. Awesome. Likely value, high value performance, and reliable based on previous purchase and positive feedback. You see? So it's picking up the customers' interactions and special circumstances, returning customers with established positive history with Corporate Prince PLC. Awesome, because this customer is happy with our services. So our key notes: opportunity to build a previous positive experience and retain customer loyalty. Focus on build latest Intel PCs, i5, i7 base PC recommendations. We prefer to match preferences and exceed expectations. Highly highlight customized options. Currently, promotions and financing provide maximum value and flexibility. So it's storing all that information about the user. So all this is stored in the customers, in basically customers long-term memory. So in this case, based on this long-term memory, we can know this customer, what he likes, what are his contact details, what are his preferences, his product that he purchased or used previously in the past. And then based on that, the chatbot can now recommend new products to this customer based on this previous purchase history which you are storing in the long-term memory. So in this case, you haven't really worked with the short-term memory in passing it into the prompt, but you can actually look at the short-term memory in depth. So you can go ahead and simply say thread. It's going to be equals to the following. So I'm going to simply say dictionary right here. I'm going to say configurable, configurable, and you're going to go ahead and pass in the following, right? So we're going to say thread underscore ID, and the thread ID is going to be the following. Going to say ID is 1, right? That's ID we use if you look at the code previously. We're going to go ahead and simply say state. You're going to pass the state because the temporary memory, the short-term memory is just the state of the graph. So I'm going to say graph, graph dot get state, and you're going to go ahead and simply pass in the thread, and you're going to say dot values, and you're going to say for message in state messages, you're going to go ahead and print each of these out. So I'm going to go ahead and simply say m dot pretty underscore print, call that, and let's see what we get back. So function build method. Okay, so I'm going to say for m in messages, and then m dot print. Yeah, that's fine. So let's look at this from here. So we're going to say configurable, and then this is going to be equals to thread ID. You're saying thread ID is 1. That's fine. We're going to say state equals to graph dot get state. We pass in the thread, and this actually values. Let's run that and see. So there's an option pretty print. Okay, let me just pretty okay, get the spelling right. Once I run that, you can see we have the short memory of the bot right here. So this is information about the bot and whatever it has stored and within the short memory or the thread scope memory. So you can see all the previous information is all in here. Yeah, so we would have to basically right now the way we have this set up is that we would have to send this short memory each time to the model, which is going to be very expensive. Imagine passing this within the context window each time, and at some point the context window will overflow, and that will lead to issues. That's why I didn't implement passing the short-term memory to the model at this time, to the LLM model at this time. So in the next video, we'll learn more about short-term memory, how to handle it. We need to kind of find a way to summarize this information, or generate a running summary or filtration. Maybe only pick the last 5 messages, right? So there's different ways of doing it. We don't want to pass all this information to the large language model. It's going to be a very expensive thing to do. So we'll handle all that, and we'll see how we can summarize all this information before we pass it on to the large language model. Yeah. So guys, that's all I wanted us to cover in this video. We have learned about building an agent with long-term and short-term memory, but we haven't taken the content of the long-term memory and inject it into our prompts yet, which we'll do in the next video once we learn how to handle the short-term memory, like summarization and filtration and different techniques, or creating running summaries and all those different stuff, right? Just to keep the short-term memory concise and not too long, and save much on tokens, and yeah, and reduce the cost of running our business or whatever you're trying to do. Yeah, so guys, that's all for this video. In the next video, we're going to look at the short-term memory, like in depth again. So in this case, you have worked with understanding long-term, we have understood short memory in terms of from the theoretical point of view, and now we have gone ahead and did a practical example, focusing more on short-term memory. So now we're going to focusing more on long-term memory. So in the next video, we're going to focus more on short-term memory and how to handle short-term memory, and then we'll learn how to inject this information now into our actual LLM application. That's what we're going to be doing in the next video. So guys, thank you guys for watching so much, and if you enjoyed this video, one of the easiest you can support the channel is just by liking this video, sharing this video with your friends and family who might find this helpful. You can also connect with me on Medium at Prince Crumper, where I write articles about this video. In fact, I post articles almost every Tuesdays. Once a week, I post articles about Gen AI applications and stuff like that. So I have a whole article for this whole series as well, in case for those of us who like reading rather than watching videos. You can read articles on Medium at Corporate Prince. You can also follow me on Twitter, on Twitter, like X at Prince_Crumper. You can also follow me on LinkedIn at Prince Crumper. In case you have any projects, you have any idea that you want us to work together on, you can follow me on LinkedIn at Prince Crumper. And hopefully, where you're watching this video is on YouTube at Corporate Prince. Hopefully, yeah, you can just subscribe the YouTube channel to support the content creation. With more subscribers, with more likes and more shares, and the more the channel grows, the better the quality of the videos will be. I promise that, right? So one of the easiest to support the channel is like the videos, share with your friends and family. Okay, get the word out there and let people know of this. Okay, so thank you guys for watching so much, and see you in the next video. Keep safe.